Greetings, my name is Tim Morosky, the owner of Mavis Games and the creative director for Antroya Chronicles Online. Welcome back to another game development tutorial, Game Dev Quick and Dirty. Today we're going to be talking about LODs. So as usual, we're going to start with how, then we're going to move on to why. So this little scene that I have set up here is basically looks exactly the same, does it not? But it's three basically very similar, but we've done some optimization techniques to these. If we look back at this one, we can see that this is actually all made up of individual static meshes. I've just got them grouped for easier selection. If I hit Shift-G here, we can deselect this, Control-G again, because I don't want to lose the group. We can see that these are actually individual static meshes. If we move back over into this area, we can see that we've got each of these broken down into merged objects, which I covered in a previous tutorial. Go ahead and look that one up. And what this is going to do is this is going to reduce the draw call from a gazillion polygons over here, or a gazillion draw calls over here, to a single draw call right here on this piece. Now we've got this all put together with merged objects, and one thing to note here, if you want to make sure you know where your pivot point is on a merged object, it's going to be the first thing that you select. So in this case, for the porch, I selected this piece first, all of these pieces second, and then merged the objects so that my pivot point ends up right there. Right where the pivot point for this was, that's where the pivot point for the entire merged object is now going to be. So let's dive in here, and we're going to discuss LODs, or level of detail. Let's go ahead and open this up. Now, I've got a bunch of these already taken care of. We're just going to quickly cover how to do this by selecting your object in your content browser. In this case, it's the shop house. We're just going to scroll down through this list over here, and we're going to get down to LOD settings. Now we're going to choose one. In this particular case, I want this to be level architecture. So we're going to select level architecture. It's going to go through its whole little building static mesh phase. And then what we can see here is it has just added 4 levels of LODs for us. So 0, 1, 2, 3. Now, one thing that we can do here is, let's say that the automatic choices that they make with this button here, auto compute LOD distances, this is generally checked on. You can turn this off, and then you can go and look through your LODs if you hit custom. So uncheck this box, scroll up to here, check custom, and that's going to open these up. Now what we can see here is at LOD 0, this piece has 21,000 tries and 19,000 vertices. Once we move into LOD 1, it's going to reduce the try count by 50%. So this is going to go down to 10,000 tries and 12,000 vertices. At LOD 2, we're at 5,000 tries, 6,000 vertices, and at LOD 3, we're at 2,000 tries, well, 2,500 tries, 2,600 tries, and 3,800 vertices. So what we can see here is that's based on screen size. So the further we move back, we can see that this just switched over to LOD 1 right up here, and our try count is 10,000. And as we continue to move back, we switch to LOD 2, try count is 5,000, and if we continue moving back, we switch to LOD 3, 2,600 triangles. Now, from this distance, you can't even really tell that anything happened. So I'm going to mess with these a little bit so that you can actually see what's happening here. We're going to take this to, let's take a look here, 5, 2, 1.25. Okay, 5, 2, 5, 2, 5, 1.25. So at half at each measure. Okay, so I'm going to take this to 9, 8, and 7. And because we're close enough to this, we can actually see what's happening here. So as we back up, we can watch things start to deform because it's shrinking up the LODs. Now, this might not be the greatest piece to actually demonstrate that. Alright, we'll do this again on the next piece, which I'm absolutely certain will have some changes here. This is actually not bad at all. Strange. Ah, there. Right there we can see that there's a shadow popping in from here. So it's basically flattening the whole thing. So what I'm going to do, I'm going to go ahead and take these back, because that actually wasn't all that bad. We'll go back down to 5. Actually, we're going to leave that at 8. That's fine right there. But we're going to take this one to 4. And we'll take this guy... Oh, this one needs to be 2. So 2... 4 and 0.8. There we go. We're going to hit save. And that LOD is now done. What do we lose that at? At LOD 2. Alright, so we're going to take this back a little further. We're going to take this down to 2.5. For the most part, the automatic ones really aren't all that bad. 2.5 and 1.5. There we go. At this point, you can't even really tell. Looks like we're still in LOD 1. That actually fades out. That's okay. Go ahead and save that. Close this. Now, for the most part, the automatic works really well, but I have a feeling this one's going to demonstrate what I'm trying to tell you about. Let me see. This one will actually be better. Yeah, we'll do it on this one. Okay, so let's go ahead and set that up again. This one, again, is going to be level architecture. Since we're going to be able to see this thing at a distance, quite the distance, most likely. We're going to take that one off, do our auto computes, and now we'll mess with this a little bit. There we go. 9, 8, 7. Alright, now watch what happens as soon as we start to back up. Watch these in particular right here. LOD 1, LOD 2. Now you can see the mesh is starting to deform. At a distance, this doesn't matter. When you're right up next to it, boy, does that make a huge, huge difference. So you can see, we don't want to see this. We don't actually want to see that happen. So we're going to set this back to 8. Call this one 4. Call this one 2. And let's see what that does for us. At LOD 1, we're fine. At LOD 2, we're still catching a little bit of deformation. So we're going to call this 0.15. We'll call this 0.2. There we go. That's good. Okay, now at this distance, we can't even really tell that that's getting all distorted. From this distance, it's pretty bad. So let's go ahead and take this one down to 0.05. We'll take this one to 1. There we go. So currently we're still at LOD 1. As we back up further, we are now at LOD 2. Oop. Went from 1 to 3. This one's supposed to be 0.5. There we go. Alright, now at 0.2, we're good. 0.5. We're so far away that that's not even going to be able to... You're not even going to be able to tell. It'll be fine right there. Hit F to zoom back in. Alright, and that basically shows us the power that LODs have. In addition, it also removes the collisions, which is kind of awesome. There we go. Alright, great. So now we're going to hit save on that. We're going to go ahead and allow these to actually compute automatically. So this one we're just going to use large prop. Yes. We're going to allow it to have its automatic settings, whatever it's going to be. Save. This one as well. This one's going to be level architecture. And for the rest of these, we're just going to allow automatic to occur, just for sake of time. I can actually go through these and touch them up later if I want to. Alright, and now our shop deck, level architecture, yes. And again, just to reiterate, if you want to change these, underneath the group settings, level architecture, uncheck this box, the auto compute LOD distances, scroll back up to LOD picker, and turn on custom. That's going to allow you to make the adjustments manually if you want to. However, for the most part, the automatic transitions do quite a good job. Okay, so now let's see how this actually performs. So I've got this set up here. I've got my stat RHI command turned on right now. And if we go up through here, we can see right now our try count is about 1.5 million, give or take. And our draw call is 900 on the max. Now, the first one that we just called in here, this is the one that has absolutely no optimization done whatsoever. So we can see our try count is quite high. 1.6 million, give or take. Now, the landmass is doing a lot of this right now, so it can't really be that close of a judge here. Probably should have just done a flat surface, but that's okay. Here's where we can see the next one. This one has no LODs. And if we run up here, take a quick trip. Keep an eye on these. There we go. We can see that our try count, nothing's really happening to it. 1.7. 1.9, almost 2 million. So now we'll run back down through here. We're going to turn that one off. And then we'll turn on the assets that we just did full LODs to, which is this guy. Now from here, you can't really make much of a difference. That's why I've got this hill to run up. Now as we come up this way, we can start seeing that number decrease dramatically. So we can see our draw calls, about 400. Our try count, about 1.2 million, give or take, which is, what, about 500,000, close to a million reduction in triangles just by doing that quick little LOD thing. So just to recap here. These ones are our assets. We take these, we use them to combine them into merged objects, like these. And then we go in, add on the LODs, and that makes this a nice game-ready, well-optimized piece. And if you want to take it a step further, blueprint the whole thing. And we'll go over that in another tutorial. In the meantime, this has been Game Development Quick and Dirty with Mabus Games. You can catch me over on Twitch TV/Mabus Games. You can find me on Facebook, and as well as YouTube, Mabus Games. And yeah, thanks for stopping by. I hope you guys found this interesting, and hit that subscribe button. Follow me over on Twitch. We'll come and hang out more. Thank you. We'll see you later.